Hey, and welcome to a new episode of IT Conversations. We're live at Red Hat Tech Day and Developer Day in Utrecht in the Netherlands. It was a so far full day of tech sessions, like no architecture, no sales blah, if you will, just like the art of the possible. What can we build today, and how can we build it, and what value can we get out of it? And today's vibe was set by the keynote speaker, Burr Sutter, and he is here with me. Burr, welcome to the show.
Thank you so much. It's brilliant to be here.
So, in short, can you explain what it is that you do at Red Hat?
So I've been at Red Hat for a long, long time. I've been at Red Hat for 20 plus years. I came as part of that original JBoss acquisition, if you remember the old school Java J2E middleware. So I come from a traditional app server background. But the entire time I've been at Red Hat has mostly been on developer experience, focusing on building developer tools, developer solutions, developer platforms. And I also helped give birth to what was our developer group that did developer marketing. So I did a lot of evangelism, DevRel, as some people call it. So I've often been a traveling person going out speaking to audiences. And these days, I am actually very much focused on the internal evangelism of AI within Red Hat.
Oh, wow.
So teaching Red Hatters how to adopt AI for their general needs in their daily lives.
Wow, and that's definitely one of the main topics of this conversation. To people who haven't seen the keynote this morning, one thing that really stood out to me is that you have a wonderful blend of storytelling, building up towards an amazing demo, but also show the art of the possible. It's and I say, like, it is beautiful because I really love the style myself as well, and I tend to do it. So, seeing someone like yourself doing the same thing, but from a vendor perspective, showing something that probably the world hasn't seen before, is just amazing. So can you kind of briefly guide us through what it is that you presented this morning and, building up towards the demo, what we saw there?
Yeah, the way I wanted that presentation to unfold was I wanted people to think through where we've been for at least a little while. So there's a little history lesson in there, but only from 2024 through 2025.
Yeah.
Because that is ancient history in the AI world at this point. But there were so many things that happened when it related to reasoning models, agentic in terms of a term, MCP in terms of a capability and a standard, leading up to what we now know as AI skills, but going along the path of vibe coding. All those things were super important innovations along the way. And we came to January 2026, where you got this thing called OpenClaw. And the moment when we understood that OpenClaw fundamentally changes the relationship between humans and AI, we've now realized that it's no longer just an enterprise AI story. It's a every human AI story. It's a personal AI story. And as that Jensen Huang quote was in a session, it's with OpenClaw, you now have the operating system for the personal AI. And so I've really been focusing on that for the last several months, even before Jensen Huang, I hope, right? And looking at OpenClaw. And I was super excited to figure out how we run that at scale. Because the other thing I ran into was when I run my own personal OpenClaw is I couldn't find any Mac Minis.
Yeah.
They sold out globally,
Yeah.
right? So you had to buy hardware for your OpenClaw instance or any kind of personal agent. So I knew that and understood that. You want to carefully sandbox it in its own hardware. And I specifically wanted to then say, great, if I have to buy hardware for this, is there a way I can just run it in a container instead and then run it at scale? So what we tried to do in that demonstration was show that you could run these things as safely and securely as possible as pods. And in this case, we actually gave 9 pods per person, so 900 pods total across 100 namespaces, all on a single multi-tenant cluster, OpenShift cluster in this case, and let everyone have their own personal assistant and personal claw.
And it worked really well. It was really fast. I did the live demo. I was in time to spin it up. I think there were like 50 seats or 100 seats.
100 seats,
100 seats. And the room was completely filled. So yeah, people around me were just a little too late to actually spin it up. But it was fast. Still, I want to kind of back up a couple of steps. You mentioned the quote from Jensen Huang, and I've been to GTC this year and actually was there. And one of the things that really stood out to me from that keynote, and that's something that you reflected on as well, is talking about agentic is one thing, but the paradigm shift we're going through is really around how to manage your factory or your data center or your cloud or whatsoever. Nowadays, we do that with a lot of engineers. Mm-hmm. But we're seeing that the agents will most likely move to become kind of the new engineers of the data center. So the agent will actually operate your your cloud. And that's something that came out of the quote as well, right? So, the importance of looking at agentic right now, but in a secure manner. I mean, been running OpenClaw for the last three to 4 months. NemoClaw, actually, so kind of the secured version of OpenClaw. But until today, I honestly don't dare yet to put it in production somewhere.
Right.
So this is something you guys have been working on for a while now. So can you kind of guide us through what your interpretation or your secure OpenClaw offering would be from a Red Hat perspective?
Yeah, I think it's a very good point. And quite honestly, even within Red Hat, this is all a brand new idea, if you will. So it's one of the things I've been pushing in terms of my own agenda within Red Hat to basically describe this personal AI moment and the opportunity to basically say that every employee in an enterprise will have 1, 2, 10 of these agents working on their behalf. That is not a concept that really was in the world, if you will, 12 months ago.
Yeah.
It really was more of an traditional enterprise application style architecture around traditional enterprise agents. And we certainly have deployed those within Red Hat, right? So it's a single agent, if you will, that might be multiple replicas of a pod, for some load balancing. But otherwise, it is a 5,000 user system. In this case, we're talking about a single user system. The whole application is for one human, right? Because it keeps their personal memories, has their personal tools, has their personal skills, things of that nature. So what really is changing in the world, and what we've been focused on, is the sandboxing concept. So you hear that term sandbox a lot, and it's highly, highly overloaded. So we probably should double click into sandbox a few different ways. Even in a conversation I was having after the keynote, the person came to me and said, oh, sandbox is like the Kata containers, those micro VMs that run on clusters. I'm like, yes, but not the only sandbox. We've also been running a public sandbox at great scale, which is a namespaces as a service using all the controls that we built into the multi-tenant Kubernetes over the years through the OpenShift team, and where you can basically say that the namespace itself has resource quotas, it has access to certain capabilities, it has certain security permissions that it can actually execute on, including like RBAC and things of that nature, right? It's role-based access control. All that's baked into the namespace concept of Kubernetes and OpenShift, and that was an area that Red Hat invested very heavily in right from the very get-go, because we run a multi-tenant cluster at scale for the public internet, and many of our customers also run it as a multi-tenant cluster in their on-premises world or across the hybrid cloud and across different cloud providers. So sandboxing is an area we can definitely spend some time on, and that's the thing I wanted to be able to visually show people today and let them experience it even, letting 100 people come talk to my cluster. And I can tell you, I went back and reviewed the logs and traces, which I mentioned in the presentation.
Yeah.
I'm centralizing the logs, centralizing the metrics, I got all the traces, and several people did try to hack our demo in real time.
Oh, really? Yeah.
Yeah,
And I think that's one of the good things, right? We already know that sandboxing, like you mentioned, is there already for a while in the platform. Spinning up containers that are non-persistent, die when you basically destroy. When they're destroyed, they're gone. Was already kind of the platform that was there, and now you bring in OpenClaw as an agentic platform into that platform. So what were kind of the challenges that you guys were facing building this?
For one, because this whole demonstration that we're talking about here, I built it kind of by myself. Well, myself and Claude, and about 2 billion tokens later. It really was about 2 billion tokens later over the course of 4 weeks. And it was just my nights and weekends kind of project, because I have a day job too. So I was building this demo mostly just on the side, if you will, just to see if I could pull this off. And for one thing, OpenClaw itself was never meant to be operationalized at enterprise scale. So you have the big OpenClaw.json file, which is where most of its configuration is. Well, how do you manipulate it in such a way and templatize it so you can have a pre-injected set of those markdown files, like the Soul MD, the User MD, Identity MD, Agents MD. So you want to get some of that pre-established, pre-injected, right? So think of that as a system prompt, if you will.
Yeah.
You want to get the right MCP servers pre-installed, which I had there. You want to out of the box ready-to-use skill, an enterprise skill. So while the user can personalize it and customize it, you want some things ready to work for them right away so they can interact with different enterprise systems. All of those things, including the centralized logging metrics and traces, well, OpenClaw did not necessarily want to accept those things. I kind of had to force myself on it, if you will, and constantly just continually to work it. Because as soon as you make a change to OpenClaw.json, right, it wants to restart the gateway.
Yeah.
So then you're kind of fighting that too. It's like, I made a change. I made a bad change. Gateway won't even restart. And now the pod is hammered. So got to kill the pod, bring it back up again, try to get the right injection into the right space in the OpenClaw JSON. Something as simple as turning off heartbeats as an example, or something as simple as adding a new MCP to the list. So there was so much of that that was hard to operationalize. And then from a pure security perspective was thinking through the network proxy layer that we had to add to this. Because the great concern for OpenClaw is not, might it invade the kernel? Typically, pods don't invade the kernel of the worker node, right? So a lot of people worry about that, but I've not heard of any of that even happening, except in scientific kind of use cases, but not with general workloads. In this case, you want to make sure it can't download a prompt injection from nefarious websites or send and exfiltrate your data back out to some nefarious website. Right, so that's the big one. The network proxy layer, I think, was such an important one, and one that we got in place here, and one we intend to put in production ourselves, running it on our public sandbox again, the network proxy layer, which is also what you see in OpenShell. Right?
Yeah.
OpenShell's primary element is that network proxy aspect.
Yeah.
At least that's how I see it.
Yeah, yeah, together with the file access, obviously.
Yeah, and
But
the
yeah,
file access, yeah.
the combination is really strong. I've been playing around with NemoClaw like at the very first day. It was 0.1 was released, and we, like in the early day. Yeah, can you call it early days even? Well, sort of. But we saw a lot of challenges with file access or network access not being detected.
Right.
While now, like 3 months later, it's already so much matured that you actually see it does work. It does detect something that's been done. How do you see the? So this is just 3 months of development. Now you shared a public link today, or it's going to be live in a couple of days, something like that, where people can play around with OpenClaw inside OpenShift as well. So what's in store? What do you see happening maybe in the next couple of months when this is going to be live? People are going to test it.
But things are certainly moving fast.
Yeah.
And we want to kind of prove this at scale in maybe a colossal, horrible way, right? Because it could very well be that it could break out of its sandbox. We didn't lock it down well enough. I don't think so, but you don't know until you try. And we have been running that multi-tenant architecture in a public cluster for over a decade.
Yeah.
So we call them the sandbox team because it's just a big sandbox in the sky, right? It's a big namespace as a service in the sky. They've been fighting Bitcoin miners for years. They've been battling people trying to inject viruses into our system for years. And so the Bitcoin mining thing, or any kind of crypto mining in general, is definitely something people try to get into the system because if they can get free compute, they will. One of the hackers today in my demo specifically tried to use all the cores on the system. Right? They wrote a quick loop in Python, because with OpenClaw, you can say, hey, help me write this loop in Python. It just iterates really quickly, set it up as a cron job, and just see if they can consume all the cores. Well, with the namespace permission model, it was like you only get 4 cores.
Yeah.
That's all you get. So the OpenClaw even responded with, I see that you want access to everything, but you're limited. So we're going to just do what you want, but we cannot get access to the entire system.
Yeah.
So again, we see that in our public sandbox also with those crypto miners as a perfect example. So we think we can pull this off, and I have great faith in the team. It's not me doing the engineering work. I'm just borrowing from their brilliant engineering. The demo I worked on today was based literally on their code.
Wow.
And so, it's just a different version based on one I had. They kept telling me last night, there's a new version. You want to upgrade? I'm like, no, I'm showing this tomorrow.
Yeah.
But yeah, they've been working on this for quite some time. And
Wow.
you're right about the trajectory of things. Our own engineering team, and like these teams, and specifically I know with the OpenClaw team too, the OpenShell team, I should say, at NVIDIA, they're practicing this agent-assisted AI, if you will, right? The agentic SDLC, they're doing what, AI-infused SDLC. There's all these different names for it. But it basically means you're trying to find ways to, submit a pull request ever faster, maybe even completely automated, maybe review the pull request ever faster, run it all through CI, which has additional checks and balances, where there's an AI in the CI, right? You might have heard of, what's the Code Rabbit one is a good example, very popular. Yeah, so all these things are part of that system now. So therefore, an application, once it finds a bug, can evolve very, very rapidly. And you see that happening with the OpenShell category, or even with this operator that I was using today that we're working for the sandbox. And I think that's just going to be our path going forward. Not to mention, every non-engineer can now build applications.
Yeah.
So we see that happening in Red Hat too. We have accountants and lawyers and financial analysts and salespeople building their own, applications for solving their own problems, and it's just kind of mind-blowing to me. I'm really enjoying this moment too, because I've always believed in the power of what you could do with amazing software. And now that everyone can build software, I think it's a brilliant thing. And it's a good thing for our society.
I think it's a great segue. Let's talk a little bit about use cases and like industries where you see this has value. Like this morning in the demo, you showed kind of a link to the CRM system. Like I had a conversation with the customer. This is basically the outcome. Can you create an offer for me? So what are next to that typical use cases where you see this basically fit?
Just to kind of double click on that use case, the reason I was so focused on it is one, that's the primary use case we have even within Red Hat. All right. So with our most important AI agent that we've created is for our own fleet of sales teams and partners and things of that nature, with thousands upon thousands of users who need that kind of capability. Because if you are someone who's a field-facing, customer-facing person, your job is to be customer-facing, not figuring out what system we drop that data in. So you have no idea what the backend CRM looks like or how that database is structured, or it's not even in that database, it's in that database or the other database. So just resurfacing the data in an AI native way, through MCP in this case, Model Context Protocol, so that the end user can just speak to it in natural language. Several people also tried Dutch today, which I hadn't thought about that too. Yeah, so I'm looking at the traces, I'm like, and there's a ton of Dutch commands in here. So that's a great example where people can speak in their own native language and get access to enterprise systems they never could figure out how to query to begin with. So I think that's huge, right? So if you think of any enterprise employee that has to access other systems, can they use natural language just to get access to it? So that is, I think, off the charts. It does also mean, though, and you kind of see it in the Wall Street performance over the last couple months, that if you are a system of record, which has had this beautiful user experience for all these years, whether it be a Salesforce or a ServiceNow or Workday or any of these big application platforms, what if the users no longer use that user interface? What if they just speak to it through their own personal agent in natural language? And I think that is definitely part of our future as a human race and within the enterprise as well. What happens when all your employees are not click, 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 click anymore, but just typing what they want, and this agent goes off and figures out how to gather that data or persist that data, like in the case of the quote builder, back to the right system in the right location.
Yeah, and this is something that I've been wondering for the last couple of years. Many of our customers built their own software, for instance. And some of the partners that we work with have their own kind of traditional, still multi-tier application with middleware, with a front end, with a database layer. And like one of the things that this will open up is like, imagine having an agent swarm at your disposal, basically just analyzing the current application and rebuilding it in, I don't know, matter of weeks. Where for a really long time, our cloud native team has been working on replatforming apps for customers, right? So we had the traditional app, the customer wanted to move towards a Kubernetes platform, so why not help them to basically migrate that monolith to something modern and help them with software architects, with developers to do that. And now, like one of the cases, and we're not there yet, I believe, but we'll be there, I think, quite soon, is that, like, why not deploy that swarm, let it fully analyze your business processes, the way you click through applications, and just rebuild it natively on top of Kubernetes. Like, this is, what do you think?
I love to use the word swarm. I don't use that word for various reasons, based on some history within the Kubernetes ecosystem and whatnot. But I do think of it from that perspective, though. It is a fleet, if you will, of agentic instances just running as pods. And now I can connect them to solve a problem, much like they would collaborate as a group of humans. If you had a group of humans, you're just like, okay, I need Sally, Fred, Joan, Juan, whatever. You guys work together to solve a problem. You can now do that with AI agents. And I do believe those run better as pods than they would on Mac Minis. And I didn't really nail this point in the presentation, I think, but it's something that's actually super powerful. Once you have people who are really engaged with their agent, this happens to me, and it's happened to many people within Red Hat. You literally see them walking around their office with their laptop lid open all the time. I've been walking around this hotel this entire time with my laptop lid open because my agents are working. And I don't want to put them to sleep. I want them to keep working. And so therefore, our CEO has to leave the office with his laptop lid open and puts it in the car seat beside him to drive home. Same thing happens for me when I'm out driving. My laptop is often open in the car seat beside me. This may sound crazy, but I don't want my agent to stop working. It's doing awesome stuff. Let it keep working. So if we ran that as pods, Kubernetes pods, instead of laptops or Mac minis, it could keep on working.
Yeah.
So that headless ability, I think, is going to be super powerful in this new world we're going to be living in. And that idea that we have multiple agents collaborating on solving a problem will be a huge idea. And then what you described about application code migration. I'll give you one concrete example where I was talking to a large customer about where they see the opportunity for GenAI and using things like Cloud Code, Copilot, et cetera. And it's one I've always known was a problem, but the problem might be semi-solved now. I wouldn't say fully solved. And that is, people were struggling with the replatforming of applications, going from the old monolithic application to cloud native architecture, moving it to a container, moving it from Windows to Linux, right? Even in that case, I've run into customers with all those scenarios. And the reason they could not move it was typically in two main categories. The current engineering team was just busy, right? They were just too busy to be bothered with it. So we'll just keep paying for that VMware, keep paying for those Windows, keep paying for that mainframe, whatever it was, because we're just too busy. There's not enough engineering time. So, well, guess what? We can free up some of that time. But the other one that I always ran into was they had never practiced CI before and never had testing before. The testers were the human end users. So whenever they do since a big monolith, they only release it once every 3 months. They let all the users know it's coming in 3 months' time. Everyone take their lunch hour and bang on the system and see if it's broken. It was a manual testing effort. So guess what you can do now also with this new GenAI solution? You can help generate some automated tests and maybe get this thing in CI. And now you're moving in the right direction. Now maybe you can decompose the monolith and make it modular. You can maybe even go all the way to microservices. But more importantly, you can validate that, it used to run on Windows, but it does run on Linux because you have test. And therefore, you can now put that in a production environment running on a container platform. And more importantly, you've actually made your team 10x more agile. I mean, we've been practicing CI for 20 years, talking about it for 20 years. Yet I find so many teams that are on what I call every now and then integration, not continuous integration, but they have their forks, their branches and whatnot, and they integrate every 3 weeks or integrate once a week. That's every now and then integration.
Yeah.
They're not all checking in the trunk every night, which is what Jez Humble says you should do, right? Everyone should check in the trunk every day at the end of your day. Therefore, when you wake up the next morning, did the build break or don't, right, or not? So that concept, I think, is super powerful, and GenAI can help us in this category.
For a while, I think Facebook was one of the companies that pushed new software every 9 seconds, I think, by heart. This will enable more organizations to become kind of a Facebook, if you will, when it comes to releasing software. One thing I wanted to talk about with you as well is, you asked the question this morning during the keynote, like who trusts OpenClaw right now? I think you phrased it a little bit differently, but the context was the same. Like OpenClaw is 12 months old? No, 14? Well,
right. I mean, realistically, it started in November of last year.
Yeah. And we've read horror stories where people ordered milk through OpenClaw, and instead of just getting one carton, they got a truckload.
Delete their production database, or send all their emails to someone else. Yeah.
Gave it a credit card, and suddenly they either earned money or lost a lot of money. Like those horror stories, and because of those stories, the trust doesn't really build. Whereas you asked the question, like who does trust it? So trust, security, compliancy is one of the biggest challenges I think we see nowadays. So what's your take on that, and what are you seeing with your customers when it comes to maybe testing or building AI, agentic AI already?
I got to tell you, I love the word trust there. I think you nailed it. We have to develop ever-growing trust around the technologies that we're bringing into our lives. And this is true at the individual level, true at the enterprise level, and everything in between. And so what you see with some of these enterprise teams, they don't even have trust in what some of us would consider a modern practice for software engineering and software development. They don't have trust in CI doing all the automated testing, as an example. Even integration tests. They might do unit tests, but they won't do integration tests and UAT tests. Well, why not? And I since I've been in the Kubernetes ecosystem so long, talking about cloud native architecture and stateless architecture for those containers, and showing people things like Istio as an example, which service mesh technology, they don't have trust in doing a blue-green deployment or even a proper base Kubernetes rollout. They just don't have trust in that. They want to do it more manually. So you have to build trust in something as simple as, oh, I do want a blue-green deployment for this application and what that specifically means, or I want to do an A/B test on this application, or I want to, any of those kind of things. A canary rollout is an example. So all three of those patterns are possible with Kubernetes, yet I find almost no teams taking advantage of those ideas that I was talking about, 8 years ago in many cases, because it was Kubernetes.
Yeah.
So I think you just have to build trust in the technique and the technology as a human group, human team, and that might be at the personal level or the enterprise level. You'll find some people that are early adopters and many people that are laggards, and they will get there eventually, but often only if forced to because of competitive pressure, because a mandate from the government, or like you said, compliance and security concern. One thing I often talked about in my presentations, I've been doing this since 2017, talking about this one key principle. I honestly believe this to be true. At least it's part of my bias for action personality. We used to tell children when they had to learn, I had to teach 3 teenage kids how to drive a car. I don't know about you, but I've had 3 kids, taught them how to drive a really big vehicle that actually costs some money. So, and they went through a lot of vehicles. My kids were not good drivers. They probably cost the 3 of them are vehicle 12 at this point. Okay? So they bounced off a lot of things. And we had to have conversations around cars should not touch cars should not touch mailboxes. Some of that, it was just all those kinds of conversations. And so, you just pay for what you get yourself into in this case. You had to teach them how to drive. And in America, you're supposed to know how to drive, right? So in those cases, with all the teaching that I had done, I saw that it takes a while for the human to learn. And it takes iterations. It takes time and commitment. And you got to make that investment. And so but the key rule we used to say when teaching kids to drive, and I think it is appropriate for children, driving cars, speed kills. We used to say it all the time. You don't go fast. You don't move. You don't go through this intersection quickly. You go slowly. You go cautiously. I think that's a human principle, right? We tend to take things slowly, cautiously. Might this kill me? And I would have that conversation. This mistake could be someone's life, right? Because that is the nature of having a big vehicle and driving down the road. So let's talk about that risk assessment, and let's really think that through. But here's what's funny to me in the modern architecture of society of software, enterprise software. I think speed is the only safe way going forward. Because if you look at the number of CVEs that are showing up within our ecosystem, within Linux itself or Kubernetes or any of the Python packages or Java packages or Node.js packages we're downloading every day, oh my God, right? There's a major 0-day vulnerability every day practically.
Yeah.
So if you don't have a system that can't be moved forward quickly, roll forward quickly, or roll back quickly, meaning that's where that A/B testing, blue-green deployment, right, rolling upgrade stuff really matters. If you're not in that cloud native architecture with a brilliant CI system, how can you even react to the CVE? And so you will run into customers that have a major critical vulnerability in their production environment for an extra 30 to 90 days, and they can't do anything about it because they only roll out software every 30 days.
Yeah.
And it's not in the Linux stack, which is easy to patch, which often it is, sometimes it's not. It's in the jar files they downloaded off the internet. It's in the pip file they downloaded off the internet. And they don't realize that the pip file, by the way, isn't just Python, there's also C code in there. Right? So there's C libraries in those Node.js packages and Python packages that a lot of people don't even think about and know about. You see if you go looking, but you don't know that you've downloaded this thing that actually depends on another library, and oh boy, it has a major critical vulnerability. Ops teams often just to kind of ignore the application stack. They don't really think about what those jar files, pips, and NPMs are, but you should. Yeah. You should worry about that. Think about your software supply chain in a big way, but speed is the only way forward. Speed doesn't kill in this case. Slow kills. That's how I see it. You got to be able to patch those things quickly and close your open doors.
Yeah, I think you hit the nail on the head in regard to speed. I mean, like we've seen a ton of customers investing in AI platforms because they wanted to change their organization. But after the investment in the hardware, the platform stack, now they have a platform, and it takes like a year, maybe 14 months to get the first use case there. And this is 100% when speed kills projects, kills ROI. Still coming back to the topic of just now around trust, like one of the things that I think that's kind of the IT mindset, right? So we always focused on predictability of services, of a platform. I want to ensure if I pull plugs or if I deploy something, it just works. And if I pull plugs, it needs to spin up somewhere else. So one thing that Gen AI does really good, really well, and Agentic AI in particular as well, is using creativity, which means that the predictability of something you ask or of an agent, shifts a bit or is different. How do you balance between creativity and predictability when it comes to Agentic AI?
It's a key trade-off decision to be made. There's so many trade-offs to be made in this new probabilistic versus non-deterministic world, right? When is it, even something as simple as when is it a tool versus when is it a skill? So I've been having some of those conversations in the hallways here at the conference, and they've been brilliant conversations. I often learn as much from people's questions and what they're concerned about as I do when I'm out teaching myself, right? So I love that ability to interact with people. And what you're describing is absolutely huge. Now, here's the funny thing. Again, I've been living in the Kubernetes world since 2015, right? So I've been kind of focused on this for like 11 years. Kubernetes itself is eventually consistent. And we started applying that idea, that principle of eventual consistency to a lot of different software architecture. If you use a Kafka-based broker within your architecture, it's because you're eventually consistent. So your predictability is based on not now, eventually. And that eventually could be a period of time you don't know and you cannot predict, and you really can't. It'll just get there eventually. And if it can't get there, you'll get appropriate errors on your little dashboards and you'll have to go debug those things. You just have to go dig in. So if people were already practicing cloud native architecture, they've felt the eventual consistency. If they've already been practicing asynchronous message-oriented middleware like Kafka and ActiveMQ and Sonic and things like that, Rabbit, all those things before that point, they would feel that natively and have trust in that. So again, this back to that trust concept, knowing that I did get it to Kafka, I know it wrote it. So at least we saved the transaction. And if we have to come back and replay it or audit it, we can, as one simple example. So like the big agent demo I did last year, the one I was doing literally a year ago, I actually showed how you could build autonomous ambient agents, all using tiny little models by breaking down the problem in ways so that it could all be passed through Kafka topics. So you had the replayability, auditability, you have the ability to go back and say, what specifically did the user do, or what was that transaction look like? And because it was preserved through the Kafka topics, I could then have another agent show up for the exception queue, right? So you can't predict everything. So the creativity you mentioned, what if you have the creativity in place and it handles 82% of the normal paths, but sometimes 10, 12% of the time, you get messages out of nowhere. You have no idea where this thing came from. You have no idea why the invoice looked that way from that particular partner or why this transaction came in from the customer support ticketing system. It just looks odd. Well, that goes in the exception topic queue, and you have another agent whose job is to analyze important data out of there. And it can then figure out, I know what to do with this, and generate its own specific code to then handle that correctly. So that was in my demonstration last year. I need to bring that one back because I've found a number of people that I've spoken to, they need that principle now. They need that pattern.
So it's a form of autonomous reinforced learning, if you will.
It's not reinforcement learning in a data science kind of way because I'm not a data scientist. I'm just a developer, is how I see it. I've been a developer for 40 years. But I've used all the tools along that 40-year period. So if you told me about WSDL and SOAP or message-oriented middleware, I worked on a team building ESBs. I worked on a team dealing with the original HTTP 1.0, things of that nature. What is a web server? I showed people how to build web servers back in the day. So I'm always thinking about, well, where can I use those same building blocks? It's like, there's situations in this new modern world, even around this Gen AI capability, especially with models in particular, because they have unknown latency. Right, your latency is completely not predictable when it comes to model invocation, and all depending on the user call. So already that's a huge level where sometimes maybe async middleware like Kafka could help you a lot, because you're just letting the transaction happen as it happens. You're using Kubernetes with its eventual consistency capability. Even this demo, right, that I set up here, there's 9 pods per namespace across the 100+ people, plus I have a backup system in case the first one fails. Well, that's a lot of infrastructure. I'm running all by myself. Well, at least me and Claude, right? But I'm using Claude as half of my ops team. Go analyze this. What's going on with the cluster? Why is that pod crash looping? And often it'll figure it out. Not always, but often it'll figure it out. And then I, the human, don't have to dig into that one. And it's something as simple as the gateway restarting because the JSON got mangled, and which is so common with OpenClaw as an example. So I think we live in this new world where if you let the tools help you and you build trust in them, which takes time on task, don't get me wrong, you got to put the hours in. So I
Yeah.
tell people all the time when I'm teaching them brand newbies to this AI world, I basically say, look, treat it as your personal agent, treat it as your personal confidant. It is, in this case, let's say running on your local machine, but be comfortable prompting. Don't Google anymore, right? Because I have people like, oh, I Googled. No, don't Google.
Yeah.
Ask the AI. It does a web search. You know, if you have the right agent, it does a web search too. So it behaves like Google, but now you can persist that memory and you can save it and it can learn over time. So it is a form of reinforcement learning, but not in the traditional data science way. You're just, in the case of OpenClaw, you're just writing markdown files,
Yeah.
right? And then it figures out, oh, I can look at my markdown files and build a skill out of that. I just love that pattern. Based on all the things we conversed on today, did I repeat myself? Oh, yes, you did. You did these 3 things. Let's make a skill out of that. So we'll remember to do that again in the future. And so Claude Code has that behavior now. Cursor has that behavior. OpenClaw has that behavior. These are just part of the new agent harnesses, right, that are out there. Hermes agent is, you know, they make that their marketing. We will always learn. We'll build skills automatically based on the conversations. I've not tested it far enough to know if it truly does that well. But even with the others, you can say, hey, you know, based on the conversation, make a skill out of that. I just love that concept of having that repeatability at least. Not pure predictability, but repeatability, reproducibility. That's more of what I'm interested in.
So, you know, we're almost rounding up the conversation. I'd love to hear from you what's next. I mean, this kind of started as a art of the possible kind of project, if you will, and we'll be sure to leave a link underneath the video in the show notes to the location where people can try it out themselves on OpenShift. So, but what's next? I mean, is this something that you're going to work on yourself, or with is it going to be like adopted by a broader team? Are you expecting use cases to come from the community? What's your idea there?
I definitely came to the Netherlands with this idea of doing a demo that I don't think anyone's seen on the planet before, right? Like really
Done. Check.
Yeah,
That worked.
And with even within the team within Red Hat, I've been showing, you know, I've been talking about this demo now for about the entire time I've been working on it, which is about 6 total weeks, as an example. I wrote the original script as here's how I want to present if I can make it work, right? Technically make it work. That's often actually how I build these presentations. I actually build a script first, like a movie director would write a screenplay, right? Here's what I think, how it would stage, how it would look. And that's often guides my engineering effort. I know that sounds funny. I don't think many engineers probably work that way, but often I figure out the story I want to work, and then make the code fit the story.
Yeah.
Because I'm a big believer in if there is no story, if it doesn't make sense to an audience, then why bother doing it?
Yeah.
You know, in many cases. So what we're going to see now is all these Red Hat engineers in particular starting to contribute to different upstreams. We got people already on the OpenShell. We got this new Claw operator, which is, you know, what I was using also with its network proxy and the network proxy in OpenShell. We're already comparing notes across 2 different open source projects in that category. We're going to launch this thing on a public sandbox, in which case we're going to prove it at scale or die trying kind of thing. And that's going to be exciting. I think that'll be very exciting. And then we have teams that are working on things like agent identity, as an example, Spiffy and Spire, so that we can actually have an identity tied to an agent. Right now, the agent is you. The agent is the human, which I think is fine for personal assistance for now. But at some point, what if they're operating in a dark factory? They're operating in an ambient agent, headless agent kind of architecture, running on those pods with the laptop lid closed. Well, they need to have their own identity so we can at least track down who did what to what. Like in an SDLC, who created the pull request? Was it a human or was it an agent? Who reviewed the pull request? Was it a human or was it an agent? At least we now know through the logging and tracing capability that it was this identity. So that's another area that I know people are very focused on. We're also very focused on agent ops right now that I'm also very excited about. You saw a little bit of it in the presentation, the metric capture, the logging capture, and the tracing capture. Beyond the traces, one of the things I'll be talking to Roberto about more is you need a feedback system too. That is super critical. That gets back into that reinforcement learning idea again also, because you can immediately see, like in one of the agents we have in production in Red Hat, when the user goes in and says, thumbs down, that was not the right answer. As a matter of fact, it got the wrong document. Here's the link to the right document. Well, that's a brilliant piece of feedback you got from your subject matter expert. Well, guess what? An agent can react to that. It doesn't require a human to go, oh, there's a correct document. Let's replace the bad document in the unstructured data set that we use to drive the agent. So that's a whole nother area that I'm interested in, and we are building more capability for. And then there's the eval system. So all this requires a brilliant eval system that you have to be able to run at scale and through a continuous integration style set of use cases. That's another key area. So there's so many areas that we're working on these building blocks. I've actually have a diagram. I didn't show it today. It's in the slide deck. So if you see the slide deck, you'll see this crazy looking building block diagram. I've had the diagram for 2 years. And we've just been working on these blocks, knocking down pieces of this wall for that period of time. And we're starting to get to the point where an agent, which is where the business value is where you can see it now running on all this infrastructure we've been working on in open source. So this has been my personal passion project really for 2 solid years now. When I heard about agents, and I knew about LLMs already because we knew about ChatGPT at that point, I was like, yes, I've always been an automator, an integrator, a builder, and so the ability to build and integrate and use systems and software, create new custom software, letting the system build custom software, letting the system build itself. We're working on one of those too, right? It's a dark factory that builds a dark factory. I know it sounds funny, but we have one of those. And so we have all this great experimentation that's happening, and we're starting to see some real return on that investment. We're starting to see some real bang for that buck. So this idea of personal agents and running any agent on top of a secured, sandboxed namespace in those pods so you can do it safely and at least monitor it. If it does misbehave, at least you got all the right monitoring at a centralized level. I think that's the thing for the next several months. So yes, the world's moving fast, but it's going to take a while for enterprises to get comfortable with this idea of giving individualized agents to individualized users. They're still uncomfortable giving Claude code to developers. I've run into that too, right?
Yeah.
So you got to get to the least, why can't a developer have an AI agent called Claude Code or Cursor or even a good Copilot?
Or open code with something local.
Yeah, exactly. Yeah. OpenCode is a great example. So one of the other teams we're working with right now within Red Hat, we're OpenCode running as pods, OpenCode swarms running as pods.
Wow.
Right. So those are the kinds of things that I've really been asking the team to really think about with me. And I'm very lucky in that we work in an open, transparent organization like Red Hat. Everything we do can be open sourced, which is a beautiful freedom that we enjoy. Everything I do, I just put out on GitHub as an example. And that's always the permission we have. And that does create a more innovative organization. Once you have the story and the vision, then people can start, saying, here's how I dock in.
So if people want to know more about the things you're releasing, the stuff that you're working on with the team, maybe follow you personally, what should they do?
So what's funny is I'm so busy, I almost don't use any social media at all anymore.
Wow.
I don't tweet or put LinkedIn post. I probably ought to. As a matter of fact, I think I'll just get my personal agent, either my Hermes or my OpenClaw, to just do that for me. And because I have been thinking about that. But I do work closely with the developers at Red Hat.com team, specifically that website. So often you'll see a lot of those articles with the folks that I'm working with in Red Hat. They'll publish the article and the blog post there. We'll try to get that content there to show these same ideas that I've just described in this conversation. So look for these things there. I'll have to get someone to go write up this OpenClaw demo I just did. I don't know if I'll do it myself, but I think maybe Natalie will help me with that as an example. But yeah, the developers.red.com site is probably the best way to find these uber geeky things that I'm interested in, because I see it all as a form of developer experience, application and infrastructure, enterprise architecture. Those are the things I'm focused on, because I like seeing the software that can actually help the user, where it really super empowers the customer. That's where I think IT matters.
Yeah.
Yeah.
100%. Burr, thanks so much for being a guest on the show. It was amazing having this conversation about agentic, about your experience this morning in the keynote, all of the developments you're running around running OpenClaw on OpenShift. It's just it has been a huge honor having you here. Thank you so much for watching this video. If you have any questions about running OpenClaw on OpenShift, we'll be sure to leave the link in the show notes. Also, we'll leave the link to the developer blog that Burr just mentioned. For now, thanks so much for watching, and I'll see you in the next video.